Biofuel, the future of alternative fuels? Let's explore. My name is Kirkwood and I'm a fuel specialist consultant at Lloyd Register, working in the FOBAS Fuel Testing and Advisory Department. Biofuels have emerged as an alternative to conventional fossil fuels in shipping, as part of the move to reduce greenhouse gas emissions from a well-to-wake perspective. Many ship owners and operators are now using or considering using biofuel on their ships. So let's dive into some key questions that you may have about what this means.
My name is Muhammed Usman and I am Product Manager Fuel Advisory at Lloyd's Register. Primarily, I deal with marine fuel quality assessment and corresponding contemporary issues. The term biofuel itself can be generic, but at a very basic level, it is considered as any fuel, solid, liquid or gas, derived directly from biogenic source such as plants, algae, and food waste. Many ship operators are currently using or looking to use biofuels, which are classed as bio-derived oil-based products, either burning them on board as 100%, also known as B100, or blending them together with conventional marine fossil fuels at various mixing ratios. One of the major benefits of these biofuels is that they are renewable fuels and can be used as a direct replacement of traditional marine fuels without the need in most cases for the large capital investment to modify ships' fuel systems or engine components.
There are various types of biofuels available, but they can essentially be divided into three main types. There is HVO, which stands for hydrotreated vegetable oil, and similar products, sometimes referred to as renewable diesel. These have been refined to a point that they are a pure paraffinic product that is practically indistinguishable from a regular marine gas oil. Then there is FAME, which stands for fatty acid methyl ester, and FAME-based fuels. These include FAME gas oil or FAME residual fuel blends up to 100% FAME. The highest quantity of biofuel being bunkered at the moment is FAME residual fuel blends, often at 20 to 30% FAME to residual ratio and referred to as a B30 or similar. The third fuel type, which can be referred to as non-standardized, really includes any that won't fit into these first two categories. This can include oils from various plant sources or organic waste products with different treatment and refining processes. This is an evolving market, so many of these products are still being trialled to see whether they are suitable for use in the marine environment and marine diesel engines. Therefore, when deciding on a biofuel, it's important to understand exactly what the product is, then follow the necessary actions based on that.
ISO 8217 is marine fuel quality standard used internationally by maritime industry to buy and sell marine drop-in fuels. So the simple answer to the question is yes, ships can purchase distillate biofuels and residual biofuels against ISO 8217-2024. It is important to note that currently ISO 8217 standard primarily considers FAME and HVO as acceptable biofuel components for blending for use as B100. However, due to high demand of FAME and HVO from other transport sectors, the maritime bunker industry is facing challenges with limited availability and higher costs. It is inevitable that moving forwards, we will see some non-standardized or new bio-based fuels in the bunker fuel mix, which is also likely to be reflected in the future editions of ISO 8217 standard.
If we look at the current most commonly used biofuels, which are FAME-based distillate and residual blends, there have not been too many major issues. With FAME residual blends, all the common problems associated with residual fuel still apply. However, the FAME can actually be an improvement to the fuel, as it will reduce catalytic fines and sulfur. The majority of problems with biofuels arise where a new non-standardized biofuel product enters the market without enough knowledge of how the product may react under the conditions of a marine engine and fuel system. For this reason, you should always be reviewing any new fuels with your fuel testing provider, so any issues can be identified early and addressed quickly. The suitability of a particular fuel will vary from one company or vessel to another. so this should be approached on a case-by-case basis. However, there are some general steps to take. It needs to be made clear from the supplier what type of biofuel is being provided. It should be purchased against an ISO 8217 fuel grade where possible, and it must be clear what sustainability certification is required and if this can be provided. In terms of fuel sampling, biofuel should be sampled in the same way and using the same sample bottles as a standard marine fuel. As with the classification of biofuels, testing considerations will depend on the exact fuel grade being used, the specific vessel, the fuel system, and the operational profile of the vessel. We recommend that this is discussed on a case-by-case basis with the vessel's fuel testing provider. Having said that, there are some common additional tests that will often be applied. For example, fuel should still be tested against the relevant ISO 8217 fuel grade, including the standard routine tests. FAME-based fuels should have the FAME content tested to confirm the percentage of FAME in the fuel blend. As FAME has a reduced calorific value, the net and gross calorific value of the fuel, sometimes referred to as lower calorific value, should be tested. On the distillate FAME blend side, oxidation stability may need to be tested. There is also a case for more extensive chemical analysis on non-standardized biofuel that is not specifically FAME or HVO based.
There are certain operational considerations that may be necessary when using biofuels in ships' fuel systems. FAME, for example, can react with certain plastics and metals, so all fuel system component needs to be confirmed as FAME compatible. To add to this, FAME can be more reactive and oxidize more readily than fossil fuels. This means storage times may have to be reduced and also storage tank conditions carefully monitored. Moreover, FAME also has a lower calorific value compared to fossil counterpart. Hence, it is important to determine the accurate energy density and use that value in an engine management systems for optimized engine operations. Compared to FAME, an HVO compliant with EN 15940 standard is a different story. It is a much more stable product as it does not contain oxygen and it also exhibits higher energy content. HVO is considered indistinguishable from fossil marine gas oil, hence ships that bunker HVO should continue to observe best fuel management practices as if they are using conventional distillate fuel.
There are key regulatory drivers from the IMO and EU for switching to renewable fuels, and biofuels, being a drop-in product, offer an immediate solution for many companies, while they may be looking longer term at other alternative fuels. IMO's target to reduce greenhouse gas emissions by at least 20% by 2030 and achieve net zero by 2050 includes requirements for improved efficiency and reduced carbon intensity, which can be met by sustainable biofuels. The EU's emissions trading system and Fuel EU maritime regulation are now also having an effect on fuel choices. For some vessels operating in EU waters, the costs of not using some renewable fuel to reduce overall carbon intensity and greenhouse gas emissions will likely outweigh any higher cost of purchasing that fuel. It is key to remember that to achieve the greenhouse gas emissions reduction benefits, the biofuel must meet sustainability criteria given in IMO and EU regulations.
The key reason for switching to biofuels is the environmental benefit they bring, specifically the recycling of carbon dioxide. This is only achieved if the biofuel is produced through a sustainable feedstock and process. Now, there are no easy way to confirm this from testing the final fuel product. So currently it is confirmed through an audit. This audit can be performed by certain international organizations and a proof of sustainability document can be issued to the fuel supplier. This document will reference an overall emission intensity value for the fuel from all stages of the fuel production and transport. This proof of sustainability document is then required by ship operators when reporting annual greenhouse gas emissions to their respective GHG verifiers. Moreover, from a fuel testing side, there are test methods which can potentially be used to distinguish the carbon isotopes within the biofuel blend, either as C12 fossil or C14 bio-derived, to help determine the levels of renewable carbon in a blend. However, we feel more research and development is required in this particular area. With the future of biofuels, I believe the key question is the availability, especially considering other transport modes and land-based industries are also after the same biogenic feedstock to decarbonize. However, in the short to medium term, there may be an opportunity for the marine industry to use certain types of biofuels which are challenging to use anywhere else apart from using on ships' combustion machinery. So those types of biofuels will not only be commercially viable but could also be more readily available. However, unknown operational behaviors and corresponding regulatory acceptance needs to be resolved, which requires industry collaboration and accelerated standardization.
FAME and HVO biofuels are produced the world over, but in current and projected volumes, the forecasts of supply are insufficient to fully satisfy the needs of the global shipping industry. In addition, the regular use of biofuels and biofuel blends by shipping companies will also require initiatives to create more widespread availability of the fuels in key bunkering locations around the world.
As the industry continues to navigate towards a cleaner future, biofuels stand out as a key area of focus, balancing the need for environmental sustainability with the practicalities of technology readiness and ease of use. I hope this video gives you a better picture of biofuels in the marine industry. LR has done an extensive amount of work to explore and examine the requirements and potential of alternative fuels. So if you would like to know more, take a look at our Fuel for Thought series at lr.org.